Today's subject is soil degradation and what can we do on it. Many soils are degraded. That means that the soil is not in its optima forma in its capacity and in its efficiency. Often too salty, often the humus is completely consumed by farm practices or by fire. And as a result, you have a soil that has low organic material, high salty, and that is very difficult to cultivate. And a lot of people say it is about climate change, but to most neutral scientific researchers, it's not about climate change. It's about how to manage the soils. If you consume organic material, you have to add new organic material to it. If you harvest everything of your plant and of your crop and not bring it back to the soil, you degrade your soil. And on long term, you make it completely desertous. So it's important to understand the impact of wrong soil management. And the soil is very vulnerable, and we can do something on it. Not just something, many things we can do on it. We first can treat it with knowledge. So, anyone who has land to farm on should know its soil. What kind of soil is it? Is it clay? Is it silt? Is it sand? Or is it a mixture of the three? Because any soil needs its own unique treatment, just like every person needs a unique treatment. Second, it needs a circular treatment of nutrients. If you take nutrients out, you have to replace it. But if you do not have organic material, then you have very little that has a holding capacity of those nutrients. Once rain comes, the nutrients will leach out. So it is important to understand the function of organic material. In today's video, we will focus on a remedy for degraded soils. And one of the remedies, what is developed the last couple of years, is to provide heavy degraded soils a well portion of charcoal, or with a modern word, biochar, which is the same as charcoal. And by providing the charcoal to the soil, you give the soil instruments to hold the nutrients and to make and to host also a lot of organisms that interact with plants and to provide the right nutrient on the right time your crop needs it. So today we will explain the role of charcoal, and we will explain how to incorporate it. I think.
Okay, so we're talking about conditioning biochar. We're going to go through a little bit of definitions here first, and then we'll get into some really practical at-home ways to do this. Biochar is biomass, wood in our case, that's been heated up in a limited oxygen environment. And basically what you're doing at that point is making charcoal. We generally heat it up a little bit further than what most commercial charcoal makers are doing. So what we're trying to do is drive everything in the wood that's not carbon out. And then simultaneously what happens is the carbon structure inside the wood rearranges, and now what we have is this really persistent, non-biodegradable carbon sponge, basically, that works on a microbial level. It's incredibly small pores. It's pretty fascinating. So what makes biochar so fascinating is those two qualities. It's incredibly porous, and it resists microbial degradation in the soil, literally for hundreds of years, if not thousands of years. Very adsorptive. So what that means is that nutrients can actually stick to the walls of biochar and stay there and can serve as microbial or plant food. So it has a buffering capacity in that manner. They are sometimes alkaline. I've measured biochar that we've made here in one of our systems that has a pH as high as 9. So consider that if you're adding that to soils that would not benefit from further alkalining. Again, we usually crush it and screen it to about 1/4 inch or so. Would save the larger nuggets and recrush it again. Here's that picture under the electron microscope. What we're talking about today is 3 different things. We're talking about biochar, which is a substrate, right? It's just a house. Think of it as a house for nutrients, and microbes follow the nutrients into the house, and what they have is a protected environment from disruptions from outside. So like heavy water events or drought, and disturbance in the soil like tilling, or over-fertilizing, under-fertilizing. Biochar is going to have a neutralizing effect on all of those. What happens when we put biochar directly in the soil without charging it? If I was to go out into my garden and apply 5% biochar to my topsoil, chances are I'm not going to have a very good crop next year, because it's going to come in and it's going to pull all the nutrients in my topsoil. It's going to hold on to them. It may take a year. It may take 2 years to recover. And that's if I have good soil with high organic matter and a nice microbial population in it already. Dead soils, damaged soils, it's not likely to do much of anything until it has microbes in it and something to eat. So again, that's what we're talking about. Nutrients, microbes. Don't forget that. Nutrients and microbes. Biochar is interesting because you can get into this really heady science where you can have a specific plant or a specific type of plant with specific needs, and you can use biochar as the vehicle for delivering specific nutrients and specific microbes to that specific soil ecosystem that you're trying to build. We probably won't get into that too much. The Compost Tea Brewing Manual describes that in some detail. If anybody's interested, happy to share. It's important to note that in most cases, nature will correct itself. Like I said, you can apply it raw. Just be prepared to wait and have a pretty disappointing crop for maybe a couple of years. Who's heard of indigenous microbes? I talk about these designer microbes and building specific soils and that kind of thing. Now, there's a good chance that the microbes in your soil are going to outcompete all these fancy microbes that we're loading in to the biochar. Indigenous microbes is certainly something to look at. Basically has something to do with sourcing good soil in a environment similar to the one that you're trying to recreate. So the example that I hear all the time is growing blueberries. If you want to grow blueberries, go find somebody that has a healthy, productive blueberry crop and ask if you can borrow a little bit of their soil. Okay, so you're going to be sourcing microbes that are symbiotic with blueberry crops. Soil food web, It's the complex relationship between soil organisms. Basically, what we're going to be looking for today in regards to biochar is diversity. Every step of the way, we're going to try to add diversity. And that is really what's fundamental to the soil food web, where if something affects nematodes in this soil food web, that there's another organism that'll come in there and kind of fill its place, and that it's a complex relationship where we can deal with a little bit of disruption. Drought and excessive rain, over-application of fertilizers, whatever. Guidelines here throughout the rest of the class, we're going to consider nutrients and microbes. Diversity, char needs to be wetted. Okay, we already discussed that. The char is hydrophobic at first. Now what happens if you take char that hasn't been wetted and you want to top dress around your apple trees?
It can stay there for a long time. I've actually used it like mulch.
Yeah? Okay. Well, that's good. I was going to say it might float away. Yeah. In a big rain event, you're just going to see it wash down the gully. Yeah, but, if it gets wetted through periodic light rains, then you're probably going to be okay. Application rates. I'll just go ahead and discuss that. I've heard wildly different recommendations for application rates, kind of depending on who you are. If you're like a down-home farmer making your own biochar in buckets, or if you're like, Cornell University scientist, you're going to have different recommendations. 1 to 10% by volume. You're probably not going to get much of an effect over 10% by volume anywhere. Talking about conditioning, that's preparing biochar for soil application through nutrients, microbes, minerals. Broadly speaking, microbes are microorganisms. When I'm talking about microbes, I'm talking about soil life, quantity, diversity of microbial life. Aerobes are those that require oxygen. Anaerobes require the absence of oxygen. In the most cases, remember, we're going to try to avoid anaerobes. Facultative are those that can actually switch between the two. When I talk about nutrients, I mean microbial foods or plant foods. We're going to talk a lot about organic matter, which is humus or little tiny bits of plants, microbes included, the waste from microbes. All of this is organic.
And market players are excited about a new product, biochar. It looks nearly like charcoal, and it actually is charred wood. But you would not brine or barbecue on it. It's far too valuable for that. Instead, biochar helps to increase the productivity of soils by increasing their capacity to store nutrients and water, and it can be used as an animal feed supplement. Also, there's a growing interest. The production of biochar is quite similar to the burning of charcoal. However, you need a different kiln. Biochar is produced at higher temperatures than charcoal. Also, during the production process, it is quenched with water. This gives it an especially porous texture with a large inner surface. Because of this, it is capable to take in water, nutrients, and other materials, just like a sponge. Michael Dejay from the Namibia Charcoal Association explains this.
We are here to look at biochar, which is a valuable addition to our products on the farm. We use thin branches, everything that you can't use for boscos and what you can't use for charcoal, so it fits nicely in between. You can use any encroached tree species in Namibia. Some of them you can't use for charcoal, but you can use all of it for your biochar because you use the thinner branches. Then coming to our production, how it's made, we use twigs that dry for about 3 months, and it's then produced in a Kontiki kiln. Then we light it at the bottom. Then after we light it, we use layers of 10 centimeter. Once you see the white ash on top, we cover it again, so you suffocate the layer underneath. Pyrolysis still carries on, and that's how we add layer on layer till you right on top. You can get out of a small Kontiki kiln, you can get about 500, half a ton of biochar out of that small size, because you fill it to the brim. And in the end, the big difference between charcoal and biochar is it's quenched with water. The water stays in. You need to watch that it doesn't catch fire. Even if you've quenched it, you still need to guard it that it doesn't catch fire. So you tip it in the Kontiki that we use here, and then you let it just dry and stabilize a little bit before you start making it smaller. You can use a hammer mill for that. We use a normal traditional stamping tool like most farmers have it on the farm, just to make it smaller parts, and then it is used in the charging process.
The use of biochar as a livestock feed supplement is a rather recent development, but already thousands of years ago, it was used by farmers in South America to increase fertility and water holding capacity of their soils. They created the famous terra preta, which means black soils. South of Windhoek at Farm Krumhoek, biochar is used today to improve soils and productivity in the market garden.
So I'm Mareike Vogts. I'm the vegetable garden coordinator. At Krumhoek we use the biochar mainly in the garden. We sometimes also use it for the chickens. They also like eating it. But our main use is in the garden. So we include it in our soils. We first charge it with nutrients and microorganisms. And we then apply it on the soil. We dig it in a little bit so that it's just in the surface about 15 centimeters of the topsoil. I think it's really a long-term investment and it will show benefits over a longer period of time. The biochar doesn't decompose, it doesn't degrade. So it stays within the soil for hundreds and maybe even thousands of years. So if you put it into your soil once, you will keep it. So the inoculation or charging of the biochar means that before we add it to the soil, we want to include the nutrients and the microorganisms into that biochar. Because if we wouldn't do that, and we would just include the biochar raw without that charging or inoculation, it would take the nutrients and the microbes from the soil first. And the process is that we take the biochar after it's milled or crushed. We use cow manure, fresh cow manure, because that has the largest variety of microorganisms and most nutrients in that manure. We have a compost tea, we use plant teas, and we have whey left over from our dairy processing. So that also is water with lots of nutrients and also the microorganisms from the dairy processing. So those are our ingredients and then we mix it with the biochar.
Biochar can be used domestically by both livestock and horticulture farmers to give nutrients back to the soil and to enhance its water holding capacity.
I put this experiment together to show the importance of soil health. In the middle, I've got 5% carbon, 2% fixed in the form of biochar, and 3% organic. Either side, I've got 0.5% carbon levels, organic carbon, which is where most of our soils sit. We're growing lucerne using no chemicals at all, and we have got superb growth in the middle, and we're struggling on the sides. We've got poor root development as opposed to great root development.
Is biochar a hype? Is it a miracle product? I would not consider that. It is one of the instruments a farmer can use to intervene into the soil. Just like you have manure, you have cover crops, you have fertilizers. Also, biochar is one of these instruments to improve the soil if conditions are there. In all cases, please ask your extension service to provide you advice what to do. Also, the rates, how much you have to provide to your soil. I personally advise around 1.5 tons of compost with 1 ton of charcoal or biochar and 500 kilo of chicken manure. Also, what is important to add to it is lime. So you can also improve the pH of the soil. The amount of lime based on soil testing, what is needed for your specific soils. This mixture of fertilizer, of biochar, and compost is an excellent product to bring on your soil every 4 to 5 years. And you will see the improvement of your soils. I want to thank you for watching this video. And if you have liked it, please like the video and subscribe for this channel. I thank you for your attention, and I hope we can provide you more information in the future. Thank you.